This video is for topic 5.1, reaction rates. The objective for this topic is to explain the relationship between the rate of a chemical reaction and experimental parameters. When we study reaction rates, we call this kinetics. So kinetics specifically refers to the rate at which an amount of reactants is converted to products per unit of time. So just like any other rate, it's a change over a change in time. When we talk about kinetics in chemistry, we're looking at a change in the concentration over a change in time. This does depend on the reaction stoichiometry. So you're going to be looking at the coefficients in the reactants and products. So here's an example reaction. We have 4 PH3s being converted into P4 and 6 H2s. So if we think about how our reactants are converted into our products, our P4 is going to be made at a quarter of the rate that our PH3 is consumed because of the 1:4 ratio. Likewise, the H2 is going to be created at a rate that's 1/6 that of the P4 or it's going to be created at 6 times the rate of the P4 because of the 6:1 ratio. So we're looking at how many reactants we're consuming to make our products. So it requires 4 PH3s to make 1 P4 and 6 H2s. So keeping that in mind, that's going to affect the rate at which how things appear and disappear during the reaction. Different experimental parameters can affect our rates of reaction. Those include concentration of our reactants, the temperature at which the reaction takes place, the surface area, so the size of the particles, and whether or not a catalyst is present and or needed to make the reaction happen. So when we think about reaction rates, we need to consider both the ratios that the reactants form our products, and then we also need to think about the reaction conditions in which it's taking place.